Okay, so section 6.5, last one. Name of it should be the triangle inequality. We're going to talk about two aspects of it. I got to get something to demonstrate with you for you here. Just a minute. I hope it still works. I'm not sure the rubber band's any good anymore, but I hope. Otherwise, I'm going to get snapped. That'll be fun. Okay. So we're on page, to discuss this, we're on page 336. However, I'm not going to follow what they do very much. I'm just going to tell you that I told you there was two things. There's actually three. None of them are very hard. Okay, about triangles in general and what we can conclude. So take a look, for example, at again a generic old triangle here, something like this. And if I tell you that this angle up here is 85, and this one is 25, and this one would have to be what? 70? Yeah. Is that right? 70? Okay. So if I tell you that, and I put some letters on here, again, this will be this one. Remember what I said about intuitive? Makes sense without having much explanation. If you know that these are the angle measures in this triangle, then it is absolutely guaranteed that the longest side is AC. And not just because it looks like it's the longest side. The reason why the longest side in this triangle is AC is because it's the side that's opposite the biggest angle. In other words, we had to open up that angle wider than any others. And as we do it, if you look at the bottom of my hands where that side would be stretched out, the wider you open that up, the longer that side's got to get, right? So the widest open angle is opposite the longest side. That makes reasonable sense, doesn't it? That means that the middle size side is what? What's the middle size side? BC. And the smallest side? AB. Now, usually they have you list them in order from least to greatest. I just did it from greatest to least. It doesn't really matter as long as you understand that the longest side is opposite the biggest angle and the shortest side is opposite the smallest angle. That should make reasonably good sense. And it works backwards too. If I have another triangle over here, and I call it PQR, and I tell you that this side here is 10, and this is 8, and this is 7, then it's absolutely guaranteed that angle R is the smallest angle because it's opposite the smallest side. So if you had to list the angles from smallest to largest, it would go angle R first, and then angle P, and then angle Q. So it works forwards and backwards. If you've got sides, you can list the angles. If you've got angles, you can list the sides in ascending or descending order, whatever they ask for. If you've got something like this, however, this is more evidence why. Let me say X, Y, Z. This is more evidence. If these two things are equal, why these two things are equal? Because if one's not bigger than the other, if these are both 7 and this is 4, then this is obviously the smallest angle, but these two are equal because they're opposite sides that are equal. One's not bigger than the other, yeah? And of course, with equilaterals, you get the same kind of thing. You got all of these the same. Since there's none of them are not any of them are bigger than any of the others, then all the angles have to be the same size. Okay, that's the first part of what we're doing today. Is being able to list angles and sides in order based on the angles and sides they're opposite of. Okay, that's one thing. The next one is if you were to go into the shop, the wood shop or the metal shop, and you pick up 3 straight things, is it possible that whatever you pick up, you'll be able to make a triangle out of? 3 straight things. Doesn't matter what length they are. You go and pick up 3 straight things out of the shop, you could make a triangle out of. Is that true? It is not. Think about this. What if you picked up a piece of strap metal? You're in the welding shop now. Strap metal it's metal that's kind of thick. It bends a little bit, but picked up a piece of strap metal and laid it on the floor, and that strap metal was 10 feet long. And the other 2 you picked up, one was 2 feet and the other one was 4 feet. So it's like this. You got a 10-foot piece of strap metal here, and you pick up a 2-foot compared to that 10 right there. That would be about this long. And a 4-foot, that'd be twice as long as that. Can you attach that 2-foot one right there and this 4-foot one over here and make a triangle out of them? As you let them fold down and try to come together, this one's going to swing down along this, and it's going to be 2. It's going to just lay down right there at 2. This is going to lay down here at 4, and there's a huge amount of difference in between. There's 4 feet in between, because it's 10 feet. That was a 10-foot piece, right? You cannot make a triangle out of any 3 things that you, or any 3 straight things that you want. There's a certain thing that has to be true, because these guys will just slam down on top of this as you're trying to get them together to form a triangle, and there's this huge desert in here. And these guys can't form a vertex because they're too short. Now, do you think that we could go and pick up a piece that was 2 feet, 4 feet, and 7 feet? You think that'd work? Well, let's think. Here's your longest one, 7 feet. That's 7. A 2 is going to stick out here, and a 4 is going to stick out over here. And if we try to bring them together, this one's going to fall clear down to here, using up 4 feet right there from here to here, right? When it slaps down on there. Are you with me? This is going to use up 2. So right here is 2 feet, and 2 and 4 is 6, and you got a foot in between that they never hit, right? Okay. Could you make a triangle out of, let's say, I'm just going to put some numbers up here instead of lengths. Could you make one out of one that is 3 feet and 4 feet and 6 feet? If you try that one, you take your longest one where you're going to attach them. You get a 3 out here. What? That's a little long. A 3 out there, maybe like that, and a 4 out here like this. And if you bring those down close enough, they are going to hit each other about there, where this is 3 and this is 4 and this is 6. Before they slam down, they're going to come together at the top. What have you learned? That the 2 shortest sides have to what? Okay, so the 2 shortest sides have to add up to the biggest one? Okay, I'm going to go with what you said first. If they were exactly, if I had 2 3s and a 6, and I had a 3 coming out here and a 3 coming out here, and I was trying to fold them down to meet, this one would fold down right there, this one would meet it right there, and there would be no triangle. So tell me again what you want to say. The shorter lengths have to, when you say more than, they each have to be more than the longest. That won't make any sense. They have to. You said it before. You just didn't say it, Ben.
Both of the shortest ones added together have to be bigger than the longest one.
That's what you just left out the word add. You just said they have to be, and so it wasn't completely clear. And Ben said, for those of you watching this, Ben said that as long as the 2 shorter sides, when you add them together, are more, that when you sum them up, there's more than this biggest side, then they're going to crash together before they slam down. If they're exactly the same, they're going to hit right here and meet right there, but it's still going to be no triangle. You have to be a little bit more. So this is what's called the triangle inequality. Given 3 lengths, a short one, number 1, plus the other short one, number 2, when you add them together, must be more than the longest one. That's the inequality. It's called the triangle inequality. What it really says, the triangle inequality just says any 2 sides of a triangle, any 2, I don't care what they are, have to add up to more than the other one. But it really comes down to short plus short, because if you got a short plus the long, it's surely going to add up to more than the other short one. Okay, so it's the 2 shortest is all you really have to establish. You get the 2 short ones, you add them together. If that number is more than the longest one, you got a triangle. If it's not, you won't. That's intuitive. Does that make good sense? Okay. Now, the last thing, and this takes a little more ingenuity, but not much. The last thing is this. If I have 2 sides of a triangle, let's say I had 5 and 8, and I don't know what that is. The question is, what could it be? Could it be 9? Yeah, because 5 and 8 is more than 9. Could it be 2?
No.
Yes, it could. 5 and 8 is more than 2. I told you the triangle inequality says any 2 sides add up to more than the third. Whether you're adding a short and a long and it's longer than the other short one, that's fine.
But what about the 2 and the 5?
Oh, yes, you're right. The 5 and the 8 add up to more than 2, but the 2 and the 5 don't add up to more than 8. Yes. You're right. You caught me. That's good. So that third side could not be 2. Could it be 6? Some of you are not participating because you don't know what we're doing, right? I've got 2 sides of a triangle. I got 2 sticks. One of them's 5, the other's 8. 5 and 8 what? I don't care. Feet, inches, I don't care. We're going to try to make a triangle out of it. What could the other side be and still make a triangle? So we've agreed that 9 will work. Yeah. Will 7? Yeah. Will 5? Will 4? Because 5 and 4 is 9, more than 8. Will 3 work? 5 and 3 is 8. That's one of those times when it was like this, right? You know what I'm saying? So will 3 work? No, it won't. Will 3.2 work? Yes, but it'll be an awfully obtuse triangle. They won't quite collapse when they meet, right? Will 14 work? Now, if I put 14 here, now these are the short ones. 5 and 8 add up to 13. So 14 won't work. Do you understand what I'm saying? Will 13 work? Nope. Will 12.9 work? Yeah. So it appears that the boundaries on this are 3 and 13. We can't be either one of those, but as long as we're a little more than this or a little less than this, it should work. So that question mark side, as long as it's more than 3, but also less than 13, it ought to work, shouldn't it? Now, for those of you that still aren't following what's going on, because it's a kind of a mind experiment, that's what this little thing is for. And I'm hoping this is still, it doesn't break on me. Okay, so here's what you have to imagine. The rubber band, even though it's kind of squishy and not very straight right now, that's the third side. These 2 sides are fixed. Let's say that this is the 8 and this is the 5. Okay? So if I put the 8 and the 5 and I hook them together down here like this, then what's the very least this could be? And what I'm saying is if I collapse that together like that, pretend that it still had a little spring in it like this. If I collapse them together like that, then if this is 5, the green one is 5 and the purple one is 8, then at that point, this would be 3, right? The rubber band would be 3 and I would have no triangle. But as soon as I made that rubber band a little touch more than 3, maybe 3.2, I've got this really obtuse triangle like this. Do you see what I mean? And it hasn't collapsed on itself. Do you understand? And as I do this, if I keep rotating this around, that rubber band side keeps getting longer and longer and longer and longer until I open it clear up. And now how long is it? 13. And no triangle. So if I shorten it up just a smidgen, now I've got a triangle. I don't know if you guys can see this rubber band on that show there. Do you understand what I'm saying? So if it's exactly 13, it's not going to work. If it's a little less than 13, it'll be fine. And anything between that 13, anything between that 13 where I had it all opened up like this. So I had 13 for the rubber band. A little bit less than that makes a triangle. And I just let that thing keep getting smaller and smaller and smaller and smaller until its other limit is 3. So long as it's a little bit more than 3, I got a triangle. That's why the third side has to be between 3 and 13. Now, how could I get these numbers right here based on these 2? Yeah, that's a track. Because look, didn't we get this when it was completely collapsed? Didn't we say that rubber band length was 8 minus 5? And when I had it all the way opened up, isn't that? Woo, keep doing this. It's hard. It's really springy. When I open it all the way up and it's flat like this, isn't this 8 plus 5? And it has to be a little shorter than that, right? So we can get the inner and outer boundaries. We just got to get the question mark where the remaining side has got to be between 8 minus 5 and 8 plus 5. It's got to be in between those 2 because what I just showed you. You following me or not? So if I had 2 sides of a triangle that were 10 and 14, what could this other one be? What's the smallest? It can't actually be 4. So that's the reason why we don't have equal signs on these, but the lower boundary is 4. And the upper boundary is 24. As long as X, the third side, is between those 2, you're going to get a triangle. that make sense? That's the third thing. So the three things that you've learned today are you can organize from least to greatest the angles of a triangle if you know how big the sides are. It has to do with opposites, right? You can also organize the angles according to how long the sides are. Does that make any sense to you what I'm just saying? Given three numbers, you should be able to determine whether you can form a triangle out of them or not. Take your two smallest ones. They give you all three. Take your two smallest ones, add them up, and if it's bigger than the other one, you got a yes. Otherwise, if it's not bigger than that, it doesn't work because it's too short. They just collapse on each other. And the last thing you learned is like unto it. That is, given two sides of a triangle, figure out what the third side has to be, smallest and biggest in between, to actually form a triangle. And it has to do with the difference in the sum, because it has to do with closing it and opening it. Good? That's it. That's it. And there's more to this section than that, but I only assigned you problems that have to do with those three ideas. And the assignment is, are you ready? Everybody ready to write? 11 to 23 odd, 11 to 23 odd, 29, 30, 33, and 36. There it is.